The basic concept in thermodynamics, what you guys have to understand, is thermal equilibrium. Now, see, to understand about thermal equilibrium, let's look at it in a very easy case. Okay. Now, let's say you take your hand, okay, and then take few drops of water. Okay, very few drops of water. Say you're going to pour it on your hand. See what happens after a period of time. The water will also come to the same as the body temperature. That is, the temperature of water will be equal to the body temperature. Now, here you guys can at least relate what is thermal equilibrium. Thermal temperature, equilibrium, which is of the same level, correct? This is thermal equilibrium. In the sense, whenever we talk about thermal equilibrium, now here let's be a little more general, okay? Here I took a very specific example of water and your hand. Let's be very, very general. Say you have two systems called as thermodynamic systems. Now, in thermodynamic systems, say A and B. Okay. Now, both of them, they have a particular state. Okay. That means when we say particular state, some temperature will be there, some pressure will be there, some volume will be there. Correct. Now, these are called as the states. Now, since we are talking about thermal equilibrium, we mainly focus or specify on the temperature of the two bodies. Okay. Now, see, I told you that you have two systems A and B, correct? Now, what exactly is a thermodynamic system? A thermodynamic system is that one which consists of a large number of particles, like extremely large number of particles. Take an example of a balloon filled with air. You have so many particles. That is a thermodynamic system. Okay, as an example, you can take a beaker of water or you can take whatever it is. These are all thermodynamic systems. Okay, now here we are talking about thermal equilibrium between the two systems, isn't it? Now what we have, suppose let's say, okay, look at this particular figure. You have A and you have B. If you look at A, you can see that there are more number of particles compared to that of B. That means A has one particular temperature, B has one particular temperature. Between A and B, we are going to place an insulating wall called as adiabatic wall. Now, adiabatic wall is that wall which is not going to let any transfer of energy from one thermodynamic system to another one. That means no energy gets transferred from A to B. Why? Because you have an adiabatic wall, okay, or what we call as an insulating wall. Fair enough? Now, let's do another one. Okay, look at this particular figure. You have A and B, again, two thermodynamic systems. Now, between these two systems, we are going to place a diathermic wall. A diathermic wall is that boundary which can, which will let the energy flow or energy transfer between the two bodies. There is exchange of heat energy between the two bodies. This is called as a diathermic wall. Now, between A and B here, when you are going to place a diathermic wall, what's going to happen? Both the systems they are going to transfer the energy. They're going to exchange the heat energy, correct? As they exchange the heat energy, what exactly happens? Both of them will come down to the same temperature. Okay, and since they come to the same temperature, we say that there is thermal equilibrium between the two bodies. All right, or two thermodynamic systems. More than bodies, thermodynamic system is the correct word what we are going to use. Whenever we talk about thermal equilibrium, we generally are going to use a diathermic wall because here energy will flow from one body or one system to another system. Okay, so this is what we call as thermal equilibrium.